Newton's first law. Newton's first law of motion is known as the law of inertia. It states that if an object isn't moving, it'll remain that way, and if it is moving, it'll keep moving unless it's acted upon by an unbalanced force, which in shorter terms means that an object will keep doing what it's doing unless a force is put on it. For example, a ball thrown in space will have the tendency to stay in motion because there is nothing there to slow the ball down. Mass is measured in kilograms and is defined as the amount of matter in an object. Inertia is the tendency of an object to resist changes in motion. This means that inertia is the tendency to move or the tendency to be at rest. The more inertia an object has, the more likely it is to stay put. For example, a bowling ball has a lot more inertia than a feather does. Force is measured in newtons and is defined as a push or pull. If you push on a box, you might say that the force you're applying to the box is 20 newtons. Types of forces. Weight is the force due to gravity on an object and is also called the force. Weight is a downward force that acts on an object. So the force that points downward in the force diagram is the weight or the force due to gravity. The force due to gravity is often put with a negative sign because it's a downward force. In this situation, the force of gravity is labeled F sub g, and it is the arrow pointing down on the diagram and the force that pulls the ball downward. The normal or support force is the force that opposes gravity. In this example, the table or other support is the force that opposes gravity. It is the arrow that is drawn upward in a force diagram. The normal force would be the arrow in the force diagram labeled F sub net. Friction is the force that opposes motion. If a car is driving to the right and has to stop at a stop sign, then friction acts to the left. The friction force would be the arrow that is either pointing to the right or the left, depending on which way the object is moving, and is labeled F sub fric. The net force is the overall force that is acting on the object. It is the sum of all the forces. For instance, if the force due to gravity on an object is negative 10 newtons and the normal force is 10 newtons, then the overall net force would be 0 newtons. An object is in equilibrium when all the forces acting on the object are balanced. This means that the upward force and the downward force are equal and balance out with each other. It also requires that any rightward and leftward forces balance out with each other. For example, if the force due to gravity on this apple is 20 newtons and the normal force is also 20 newtons, then the apple would be in equilibrium because when the force due to gravity is subtracted from the normal force, the net force is 0.
Newton's second law. Newton's second law states that the net force and acceleration of an object are directly related to each other, while the object's acceleration and mass are inversely related to each other. The equation typically used for Newton's second law is F equals ma. If a ball had a mass of 5 kilograms and an acceleration of 2 meters per second squared, then the force on the ball would be 10 newtons. Acceleration is measured in meters per second squared and is the change of speed or velocity. Direct proportion is when two variable quantities have a ratio that remains constant. When one increases, the other does as well. Inverse proportion is when two variable quantities have a ratio that is opposite of each other. When one increases, the other one decreases, and when one decreases, the other increases. For example, if you had a bowling ball that weighed 2 kilograms with an acceleration of 2 meters per second squared, the force would be 4 newtons. If you double the acceleration, then the mass would double as well. They are directly related. Another example is if you had a bowling ball with an acceleration of 2 meters per second squared and its mass was 2 kilograms. The force would also be 4 newtons. However, if you do multiply the acceleration by 2, then you will need to divide by the mass by 2 also, to get a force of 4 newtons.
Third law. Newton's third law states that for every action there's an equal and opposite reaction. This means that the force of one object on another object is the same as the force of the second object on the first. The forces are equal to each other, they are just in opposite directions. For example, if 2 people are playing tug-of-war, then the tension force that one person is putting on the rope is the same as the tension force the other person is putting on the rope, just in opposite directions. If one person puts a 10 Newton force on the rope, then the other person would put a negative 10 Newton force on the rope.
Interaction is a mutual action or influence. For example, a baseball and bat interact when they hit each other. Action is the process of doing something. The force of the ball on the bat is an action. Reaction is an action in response to a situation or event. The force of the bat on the ball is the reaction. To recap, Newton's first law states that anything in motion will stay in motion and anything at rest will stay at rest. Newton's second law states that the net force and acceleration of an object are directly related to each other, while the object's acceleration and mass are inversely related to each other. And the third law is, for every action there is an equal and opposite reaction.
Thanks for watching!